Hi, welcome to Algebra 2 Common Core. We're going to begin a new unit today where we study the circular functions. So in lesson number 1, we just want to be introduced to some of the terminology that we'll be using, and we'll practice drawing some of these angles. So in this unit, we'll be studying the 3 basic trig functions. You were introduced to those trig functions in geometry: the sine, the cosine, and the tangent. We'll be getting to those further into our chapter, and we'll be analyzing them quite a bit more than you did in geometry. These functions are based on the geometry of a circle and the way that angles can rotate around the center. So we're going to take a look at the picture that we've got drawn on our note packet here. First of all, I want to point out the axes. Here we have our x-axis and our y-axis, and we have a circle drawn where the center of the circle is at the origin. Now we are going to want to place angles on this circular figure. So first of all, we see that we've got what is called the initial side of our angle. The initial side is, of course, the beginning side of the angle. Then we have the terminal ray. The terminal ray is the ending side of the angle. Just identifying the quadrants, you should be used to this being the first quadrant. This quadrant is called the second quadrant. Over here we've got the third quadrant, and here the fourth quadrant. So a quadrant just means 1/4 of my diagram, or 1/4 of my unit circle. So start with the definition of a standard position. So an angle is drawn in standard position when its vertex is at the origin and when it has an initial side, an initial ray, that is along the positive x-axis. So we're always going to draw our angles so that they begin over here at my initial ray on the x-axis. The terminal ray is going to determine how big that angle is. So let's talk about one kind of angle here, a quadrantal angle. The quadrantal angles are defined as the angles that are formed by the axes. If we look at the measurements of them, these angles have measures that are multiples of 90 degrees. So for example, if my initial side, my initial ray, is right here along the x-axis, and my terminal ray is also along the x-axis, so my angle actually looks just like this. The beginning and the ending are both exactly the same. That tells me that my angle would be a measure of 0 degrees. I haven't gone anywhere. I haven't rotated at all. If, however, I have my initial ray right here along the x-axis, which it always needs to be, and my terminal ray going along the y-axis in this direction, then the angle that I have rotated through would be an angle of 90 degrees. And I can see that the 90-degree angle is formed by the positive x-axis and the positive y-axis. Now, if instead my terminal ray comes all the way over here, then I'm going to see that my angle would be starting at the initial ray, ending over here at the terminal ray, and in this case, I would have an angle of 180 degrees. So I can see that I'm counting by 90 degrees. If I continue around the circle, and instead of stopping at that negative x-axis side, I instead come all the way here from this initial ray, then I'm measuring my angle this way, and I've gone 270 degrees. Continuing around the circle, I can, once again, make my initial ray along that positive x-axis and continue all the way around once, making the terminal ray also there. So this time my angle is a complete circle, so that makes 360 degrees. So I can't really tell the difference between an angle of 0 degrees and an angle of 360 degrees because they both have exactly the same initial and terminal sides. Now my angles can actually go bigger than one circle if I continue around the circle. So continuing on, the next quadrantal angle would be 450 degrees. So I continue counting by 90 degrees. But we'll refer to those quadrantal angles quite a bit. Now when we talk about the rotation, every time I did a counterclockwise rotation, a counterclockwise rotation means that when I am starting at my initial ray, I go this direction to my terminal ray. That's going to be a positive angle. If, on the other hand, I go exactly the opposite direction, so starting at the initial ray and this time sweeping around and rotating this direction, then what I'm going to see when I have a clockwise rotation is a negative angle instead. So we're going to practice drawing some of these angles in our examples that follow. So you'll see that in example number 1, we want to draw the angles given by each measurement that's given to you. Just to point out a notation here, the Greek letter theta, and it's pronounced theta, very often represents an angle measure. So when we're talking about angles, we very often use Greek letters, and this is one that we're going to see quite a bit. So for each of these, we want to draw where that rotation would be based on the fact that we know what our quadrantal angles are. So you may even find it helpful to start out, especially at the beginning, and put in those quadrantal angle measurements. Now, we are never in Algebra 2 going to use a protractor to measure our angles exactly. We're just going to be estimating where they would end. So for a 145 degree angle, I'm always beginning at this initial side over here along the x-axis, the positive x-axis. I know that my angle has to be bigger than 90 degrees, but smaller than 180 degrees. It would be a little bit closer to the 180, so I'm going to draw my final or my terminal side right there. And I'm going to show the direction of the rotation by putting a little arc. That angle would be 145 degrees, approximately. Now, what quadrant have I ended in? I see that my side ended in quadrant number 2. Let's try the second example, 320 degrees. There's my initial side. 320 degrees is bigger than 270, but smaller than 360. And it's just barely past halfway. So from my initial side, I'm going to go about here. But make sure that you're going in a positive counterclockwise direction. So that's 320 degrees. And again, always show the direction that you're doing your arc. Where did I end this one? This is quadrant number 4. 72 degrees. Here's my initial side. 72 degrees falls between 0 and 90. So that tells me I should be closer to 90 degrees, so I'm going to have an angle that looks approximately like that. And here's the direction of my rotation. This clearly ends in the first quadrant. Now, what's going to happen when I have a negative angle like D? Here is still my initial side, always, always, always along the positive x-axis. Negative 210 degrees just means that when I take my rotation, I've got to go in the clockwise direction. Now, be sure you see how much you have to go. If I go this much right here, that's 180 degrees. So I have to go further than 180. So I am going to show my terminal side right about here, and I'm going to show the direction of the rotation looking like this. So this is going to be an angle of negative 210 degrees. I've completed that angle with my terminal side in quadrant number 2. Now what I'd like you to do is take a few minutes and try E and F and then come back and check with my work. So I've drawn an angle of 250 degrees, and that one goes in the positive direction and ends in quadrant 3. And then I drew an angle of negative 310 degrees, and that went in the clockwise direction, the negative direction, and ended in quadrant number 1. Now you're probably wondering what happens when we get past 360 degrees. Well, my initial side is still going to be right there. Oop, I want that to be right along the axis, so let's try that again. There's my initial side. Now to go 360 degrees, I've got to make a complete rotation. But I've got to go 100 degrees beyond that. So there's another 90, and then an extra 10. So I see that I'm going to end this way, and I'm going to show that rotation. I am ending in quadrant number 2. For negative 400 degrees, there's my initial side. Go completely around to make negative 360. Now I've got to go an extra 40 degrees in the clockwise direction, and I see that that ends in quadrant number 4. So if given any angle, you should be able to draw the rotation, and you should also be able to tell what quadrant that angle ends in, based on where your quadrantal angles are. Our next definition is for coterminal angles, and you can probably guess from the name of it what a coterminal angle or what coterminal angles would have to be. Any two angles that are drawn in standard position that share a terminal side are called coterminals. So let's start with our first picture. Again, notice I am designating the angle. This time it's the Greek letter called alpha. So alpha is equal to 90 degrees. So first of all, I'm going to draw my 90-degree angle. So there it is right there. So if I want my terminal side to be the same, well, let's see here. This direction I know I've gone 90 degrees. But if I want a coterminal angle, I could go the other direction and say, oh, well, if I reach the terminal side going this way, that's going to be negative 270 degrees. So there's an angle coterminal with 90 degrees. Now I could also take my angle and start with my initial side, go completely around, and then finish off by going back to the terminal side. That would be a total of 450 degrees. So two coterminal angles with 90 degrees would be negative 270 and also positive 450. Let's try 330. Here's my initial side. 330 is going to end over here in quadrant number 4. So that's an angle of 330 degrees. Could I go the opposite direction? Of course. So if I rotate that way, it's going to be an angle of negative 30. Do you notice that the absolute values of the two angles when added together would be 360? I could also do a rotation of completely around the circle and then finish off by coming back to that 330. How am I going to make that angle? 330 plus a complete rotation of 360 gives us a total of 690 degrees. Now, there's actually an infinite number of coterminal angles because I could go around the circle any number of times. Do me a favor and take a few minutes to try C and D and then come back and check. I want you to try to find two angles that are coterminal with each one. So the other two examples, 120 degrees would be coterminal with negative 240 and also with 480. Positive 210 degrees would be coterminal with negative 150 degrees and also 570 degrees. So did you notice that when I have coterminal angles drawn in standard position, their measurements always differ by a multiple of 360 degrees. So I can continually add 360 degrees each time to get another coterminal angle. The last type of angle that we're going to talk about tonight is reference angles. Reference angles are formed when I make a positive acute angle from the terminal ray to the x-axis. You'll see as we draw our diagrams. So in example number 4, it says for each angle, this time we're using the Greek letter beta. You'll notice that this is just the Greek form of the letter B. We want to draw the rotation diagram and then find the reference angle, and we're going to call it beta. So B with a little r stands for reference angle. So starting with my angle of 160 degrees. Start by drawing 160 degrees. So that's going to be in quadrant number 2. There's 160 degrees. Now the question is, let's go from that terminal ray, so right here, to the x-axis. Now, which side of the x-axis do I go to? Whichever side is closest to that terminal ray. So I'm going to go right here to this side and find this angle right here. So if I've got 160 degrees to get to that quadrantal angle of 180, I would have to say that the reference angle is equal to 20 degrees. That's how far away I am from the x-axis angle. For 300 degrees, here's my initial side. 300 degrees is going to be past 270. So this right here makes 300 degrees. That's beta. We want to know how far will it be for me to go from that angle to the next closest x-axis angle. So to go from 300 to 360, I see that the reference angle this time would be equal to 60 degrees. Let's go ahead and look at 210 degrees, which is in the third quadrant. 210 degrees looks like this. Where's the closest x-axis? It's okay to go backwards to an x-axis. So we're going to say how far away is that? It's always going to be the positive value. So I'm going to say, okay, from 210 back to 180, that angle right there, that reference angle is going to be 30 degrees. So I'm always measuring from the x-axis, and I always want my answer for the reference angle to be positive and acute, meaning that it's smaller than 90 degrees. 78 degrees, here's my initial side. Here's 78 degrees. Well, when I look at that angle, it's going to be closest to this right here. How far away is that terminal side from that positive x-axis? The reference angle this time is just the angle itself, 78 degrees. Now, what happens when I'm talking about negative angles? I'm going to draw them the same way I'm used to here. Here's my initial side. Here is going to be negative 90. So I need to go negative 110, which is going to be right along here. So if I've gone negative 110 degrees, the question is, what will it take to get me back to the closest x-axis? So I'm going to say, okay, negative 110 to go back to 180 is going to be a difference of 70 degrees. So my reference angle, 70. Negative 280 degrees. Well, let's see here. That means that I go 270 in the clockwise direction and a little bit more. So that angle is negative 280. To find the reference angle, I just want to know how far away from this part of the x-axis am I. So 280 from 360 gives me a reference angle of 80 degrees. And again, you'll notice that all of our answers turn out to be positive reference angles, and all of them are acute because they are less than 90 degrees. Now for 605 degrees, that means I'm going more than once around my circle. So once around gives me 360. If I continue along, 605 minus 360 tells me that I need to go an additional 245 degrees. So here's 90, here's 180, 270. I don't want to go all that way. I want to stop right about here. So that's going to be an extra 245 degrees. How much have I gone past, or how much is it to go back to that x-axis angle? I would just say 245 degrees minus 180, which gives me 65 degrees for my reference angle. For the last one, let's do negative 410. There we go. There's our initial side. Go around for a negative 360. Notice that I went clockwise. And I'm going to end right about here, another 50 degrees in. So how far is that from the closest x-axis angle? I'm just going to say 410 minus 360. Notice that I didn't use the negative 410. I just used the fact that I've gone 410 degrees. When I subtract that, that gives me 50 degrees. So my reference angle there, 50 degrees. So we've done a lot of work on establishing the background information for our rotational angles. And we'll keep working on these angles tomorrow in class. Make sure that you can tell the difference between a reference angle, coterminal angles, and, of course, all of the original definitions of our quadrantal angles and the direction of rotations. Have a great night, and we'll see you next time.